Hey there, science fans! Ready for some explosive fun? Ever wonder why some folks love watching things explode in a safe and controlled environment? It's not just about the bang. Part of it is the spectacle, the awesome display of energy and light. But there's also a deeper fascination with the unseen forces at play, the chemical reactions that make it all happen. These reactions are like nature's magic tricks. Chemistry is cool, and some chemical reactions are cooler than others. They can be mesmerizing to watch. Some reactions are downright dangerous, and understanding them is crucial for safety. Knowing the science behind them can save lives. Today, we're diving into the exciting world of dangerous chemical reactions. Buckle up, because it's going to be a wild ride. We'll explore what makes them tick and why it's so important to respect their power. Safety first, always. From explosive compounds to reactions that generate intense heat or toxic fumes, these are not to be taken lightly. These chemical transformations remind us of the incredible forces present in the natural world. They are both beautiful and terrifying. Don't try these at home, but let's explore them together. Stay curious and stay safe. Fluorine, sitting at the top right corner of the periodic table, is the smallest and most reactive non-metal. Its unique position in the periodic table gives it some fascinating properties. This tiny element has a big personality when it comes to chemical reactions. Its high reactivity is a defining characteristic. Fluorine is so reactive because it desperately wants to gain an electron and complete its outer shell. This drive makes it highly aggressive in chemical interactions. When fluorine encounters other elements, it rips electrons away with incredible force, forming strong bonds and releasing tremendous energy. This process is both fascinating and powerful. This makes fluorine reactions incredibly exothermic, meaning they release a lot of heat. The energy released can be quite dramatic. One famous example is the reaction of fluorine with hydrogen. This reaction is a classic demonstration of fluorine's power. Mix these two gases, and you'll get an explosion and a burst of hydrogen fluoride, a highly corrosive acid. The reaction is both spectacular and dangerous. Fluorine's reactivity makes it a key component in rocket propellants, but it also demands the utmost respect from chemists. Handling fluorine requires extreme caution due to its potential hazards. Ever heard of nitroglycerin or TNT? These powerful explosives belong to a class of compounds containing nitro groups, NO2. These nitro groups are like tightly wound springs just waiting to be released. When exposed to heat or shock, these compounds undergo a rapid decomposition, breaking down into nitrogen gas, water vapor, and other gases in a fraction of a second. The sudden formation of a large volume of gas creates immense pressure, leading to a powerful explosion. What makes these reactions particularly dangerous is their sensitivity. Even a small impact or spark can trigger a massive detonation. That's why explosives like dynamite require careful handling and storage to prevent accidental detonations. Section 4. When water attacks. Alkali metal mayhem. We all know water is essential for life, but did you know it can be dangerously reactive with certain elements? This is especially true for a group of elements known as alkali metals. Alkali metals, like sodium and potassium, are highly reactive metals that react violently with water. Their reactions are not just vigorous, but can be quite explosive. These metals have only one electron in their outermost shell, and they desperately want to get rid of it to achieve a stable electron configuration. This single electron is the key to their reactivity. When they come into contact with water, they donate their outermost electron to water molecules, splitting them apart. This process is both fascinating and dangerous. This reaction produces hydrogen gas, which can ignite due to the heat generated by the reaction and a strong alkali solution. The heat and gas together create a volatile situation. The reaction is even more violent with heavier alkali metals like potassium and rubidium. These metals can cause explosions that are both spectacular and hazardous. So, remember, while a dip in the pool is refreshing, a dip in a pool with alkali metals is a recipe for disaster. Always handle these metals with extreme caution and respect their reactivity. Section 5. Respecting the power of chemistry. From the explosive power of nitro compounds to the fiery reactions of alkali metals, we've seen how some chemical reactions can be incredibly dangerous. These reactions remind us that chemistry is a powerful force, and understanding these reactions is crucial for our safety. By studying these reactions, chemists can develop safety protocols for handling hazardous materials, design safer explosives for controlled demolitions, and create new technologies that harness the power of chemistry for good. So next time you hear about a chemical reaction, remember the awesome power it holds and the importance of respecting the forces at play.